Hello everyone. Our topic for assignment is serial and parallel processing and Flynn's classification. This assignment is done by D12 group. Our members are Atharva Deshmukh, Om Deshmukh, myself Samruddhi Deshmukh, Satyajit Deshmukh and Soham Deshmukh.
I will explain serial processing. In serial processing, firstly we will see it may sound advanced, but serial processing is actually a pretty simple technique. In fact, you may already be using serial processing in your mixer without even knowing it. Serial processing is simply using more than one the same type of plug and in signal processor on an instrument of a vocal. For instance of using one compress to apply a 10 dB or gain reduce, you would use the two compression in serial to apply 5 dB of gain reduce each. The comparator don't have to be back to back in the signer chain, just as long as they are both applied to the same channel. By splitting the work different between two compressors, you are able to achieve the desired amount of gain, reduce the transparent result. For must plugging, split the work between two processors, trained to sound better than having one more processor do all the heavy lifting. Analog compression, like a Universal 1776, are known as their ability to crush vocal with up a 20 dB of compression to create a adult controlling vocal sound. Second, I will explain advantage and disadvantage. Advantage: serial processing refer to a execution of task or instruction one after the other in sequence manner, when each task or instruction must be completed before the next one can begin. I will explain advantages firstly. In first, simplicity. Serial processing is a simple to implement and easy to understand. It does not require complex algorithm or parallel hardware architecture, which make it suitable for small scale system. Second, deterministic. Because tasks are executed in a strict sequence, the outcome is predictable and repeatable. It makes it easier to debug and test the system. Third and last but one is resource sharing. Serial processing allow for different resource sharing, as each task has access to the entire system resource. The ensure that there are no resource outgoing or rare condition. Fourth and last one is easy to maintenance. Because each task is executed one after the other, it is easy to maintain the system and ensure that its work so expected. Second disadvantage. In disadvantage, first is slow performance. Serial processing is slower compared to parallel processing. This is because tasks are executed one after the other and each task must be completed before one task started. Second, limited scalable. Serial processing is not a scalable, as the system performance is limited by the speed of the processor. This means that as the system grows, the performance of the system decreases. Third and last but one is insufficient use of resource. Serial processing can lead to insufficient use of resource. For example, if task is require a lot of processing power, it may hold up entire system and prevent their task from running. Fourth and last but one is lack of flexibility. Serial processing does not allow for a much flexible, as its tasks must be complete before the next one begins. The limit of the ability and the system of sharing condition or requirement. We will first thank you. See, parallel processing can be described as the class of technique which enable system to active simultaneous data processing task to increase communication speed of a computer system. Second is parallel processing system can carry out simultaneously data processing to a faster than execution time. For instance, while an instruction is being processed, ALU component of CPU, the next instruction can be read from memory. The primary purpose of parallel processing is to enhance the computer programming capacity and increase throughput. Example, as we see, the amount of processing that accumulation during the given interval of time. A parallel processing system can be achieved by having a multiplicity of function units that are perform identical or different operations simultaneously. The data is distributed among the various multiple functional units. And in following diagram show one possible way to separate the execution unit and function unit details in parallel. I will also explain parallel processing. In there are mostly three types. The ladder and internal multiple perform the arithmetic operation with integer number. Second is the floating point operation are separate into three circuit operation in parallel. Third and last one is the logic shift and increment operation can be performed consequently on different data. All units are independent of each other. No one can depend on each other.
Now we will discuss the advantages and disadvantages of parallel processing. Now firstly we will see the advantages of parallel processing. In that, first, speed up. The primary advantage of parallel processing is speed up. By dividing a problem into a smaller parts and processing them in a parallel, the overall computation time can be significantly reduced. This is especially true for the large scale data analysis, scientific simulations and complex numerical calculations. Second one is scalability. That parallel processing is highly scalable, meaning it can handle the increasingly larger workloads without sacrificing the performance. This is because more processors can be added to the system and workload can be distributed among them. Third one is increased productivity. In that, parallel processing can increase the productivity of an organization by allowing the multiple tasks to be processed simultaneously, reducing the overall processing time and improving the efficiency of the system. Fourth one is cost effective. Parallel processing can be cost effective as it enables the use of less powerful processors. For example, a cluster of low cost processors can be outperform a single expensive processor. Now we will see the disadvantages of parallel processing. First one is complexity. Parallel processing can be complex and challenging to implement. It requires specialized hardware, software, and the algorithms that are optimized for parallel computing. Second one is communication overload. Parallel processing involves the communication between the processors, which can result in the overhead that reduces the overall performance of the system. This is especially true for the distributed systems where processors are geographically dispersed and connected via network. Third one is load balancing. Load balancing can be a challenge in parallel processing as it involves distributing the overload and processors evenly. Load imbalance can result in underutilized processors and reduce overall performance. Fourth one is debugging. Debugging parallel programmers can be challenging as errors can occur in the processor, affecting the entire system. This can make it difficult to isolate and resolve errors. Conclusion: parallel processing can be a powerful tool for speeding up complex computations and increasing productivity. However, it also has its challenge and requires specialized knowledge and expertise to implement effectively. Here we will see the Flynn's classification. Flynn's classification is a taxonomy that categorizes computer architectures based on the number of instruction streams and data streams that are processed concurrently by the processors. It was proposed by the Michael J. Flynn's in 1966 and is also known as Flynn's taxonomy. Flynn uses the stream concept for describing a machine structures. A stream simply means a sequence of items, that is data or instructions. The classification of computer architectures based on the number of instruction streams and data streams. There are four types of Flynn's classification.
Single instruction, single data, SISD. In SISD architecture, there is only one processor that executes a single instruction on a single piece of data at a time. This architecture is the simplest and is used in traditional von Neumann machines. At one time, one instruction operates on one data. SISD corresponds to the traditional single core uniprocessor. A single data stream is being processed by one instruction stream. A single processor computer in which a single stream of instructions is generated from the program. Single instruction multiple data, also known as SIMD. In SIMD architecture, a single instruction is executed on multiple pieces of data simultaneously by multiple processing elements. This architecture is often used in graphic processing units, also known as GPUs, and digital signal processors, DSPs. At one time, one instruction operates on many data. Data parallel architecture. Vector architecture has similar characteristics but achieve the parallelism and pipelining. Array processors. Multiple instructions, multiple data, MIMD. In MIMD architecture, multiple instructions are executed on multiple pieces of data simultaneously by multiple processors. This is the most common architecture used in modern parallel computing systems, such as clusters and distributed systems. Most common and general parallel machine. Each processor has a separate program. An instruction stream is generated from each program. Each instructions operate on different data. Several processing units operate on multiple data streams. Programmers normally write a single program that runs on all processors of a MIMD computer. Multiple instruction, single data. MISD. In MISD architecture, multiple instructions are executed on a single piece of data simultaneously by multiple processors. This architecture is not widely used in practice as it is difficult to achieve a significant speedup in most applications. Systolic array is one example of MISD architecture. Systolic array is a homogeneous network of tightly coupled data processing units called cells or nodes. Each processor executes a different sequence of instructions. In case of MISD computers, multiple processing units operate on one single data stream. In practice, this kind of organization has never been used.